Sliding window problem itself is very easy to understand on what we need to do in the problem. But the solution of the problem is something which I have not find anyone else anywhere to explain it as intuitively as it could be impossible to do. So I am giving it an attempt to explain it. Hey guys, this is Abhishek. You're watching CodeWord. Let's get started. I will explain you the problem statement with an example and then we'll dive into how we are solving it. In this example, we have 8 elements in the array and we have a window size of 3. I am also keeping tab on the start index and end index of the window size. I would not be keeping that stored inside the algorithm. Reason being that it should be very simple to calculate the start index and the end index at any point in the array. So we'll be moving the window from left to right in the DQ and we try to find out the maximum inside each window with each iteration. For example, in this case, the window is spanning from 0 to 2 because the window size I've taken it as 3. The maximum out of these 3 elements, which is 3, would be stored in my result. Now the window would move one step to the right and will span from 1 to 3, and that the maximum is 3. So again 3 would be stored into the result array. And then the window would move from 2 to 4. The maximum would be 5 in this window, so it will be stored 5. Then again the window would move from 3 to 5. The maximum is again 5, so it will be stored in the answer. And then in the final 2 steps it will move from 4 to 6 where the maximum is 6, and then at last it will move from 5 to 7 where the maximum is 7. Now how we will solve this is we'll be using data structures to solve it. We want two things from a data structure. One, we want the data structure to always give the maximum, and the second is if we want to maintain only the elements which are inside the window inside the data structure. So I'll have to modify the data structure in such a way that whenever I try to get an element from the data structure, I always get the maximum in the window, and the data structure almost by in itself is able to remove all the elements which are going out of the window. So whenever an element is going out of the window, it takes a note of it and basically just removes it from the data structure. I'd be using DQ for it. Reason being, if I want my DQ to give the maximum element at any time we peek from the DQ, we need the DQ to be storing the elements in the descending order from left to right. So whenever I'm picking an element from the left, I would be getting the maximum from the DQ. The second thing is that at each iteration, I need to remove the elements which are going out of the window from the DQ, and that I'll be doing from the left. Let's see how it goes. Here, this is the algorithm where I need to have two inputs from the user, the array and the window size. In this example, I'm taking window size as 3 and the array as this one, which you're seeing on the screen. In the first part, I'll be initializing my DQ and my result array. In the next part, I would be seeing the first element from the array. So this loop is basically seeing the iteration. It is moving the window from left to right one by one. It has 3 parts, 3 important parts. The first part is where the logic remains to remove the elements which are going out of the window. The second part is to push the elements into the DQ in such a way that the DQ always remains sorted from left to right. And the third part is to build the solution into the result array. So here is how it is happening. We are seeing the first element in the array, and then you would be pushing this element into the DQ. Minded, we are not pushing the element itself. We are storing index inside the DQ. Reason for this is that it should be easy for us to know if the elements inside the DQ are actually in the window or not, and that can be easily done if we just store the index and compare it with valid window indexes. So that's why we are storing the index into the DQ. Now we saw the first element and we pushed that element into the DQ. Whenever I say I'm pushing the element into the DQ, I'm pushing the index of that element into the DQ. Just make note of that. I pushed one inside the DQ, and then this particular part of the loop doesn't come into the play until unless I see the minimum number of elements required for starting to build my solution. So I need to see at least 3 elements before we actually move inside this loop and start building my solution. So we are pushing something in my result array. So I'll move to the next element in the array, which is 3, and I need to push 3 into the DQ, but I cannot directly push 3 into the DQ because I need to maintain DQ in such a way that it's sorted from left to right in descending order. Reason being that whenever I pick an element from the DQ, I need to have the maximum out of that DQ, and that can only happen if I have the maximum element as the topmost element. And whenever the topmost element goes out of the window, we would need to pop it out. So the next incoming element should also be the maximum into the DQ. That's why we want the DQ to be sorted in descending order. It should be maximum from here and the minimum should be on the rightmost. So I cannot push 3 directly into the DQ. I'll have to pop 1. The other reason for that is, why are we popping 1? Is it even worth keeping 1 in the DQ? Because we're building our solution out of the DQ, and 1 can never be into the solution anymore because I've already seen a better element for us, which is 3, which will be in the solution even before 1. So it's a higher element than 1 and it's coming later in the queue. So in any future upcoming windows, 3 would be preferably taken up and 1 will never be come into my solution. So I need not keep 1 into the DQ. So I'll be popping 1 and pushing 3 to maintain the order of my DQ. So this particular part of the code will be popping index 0 out of the DQ and pushing 3 into the DQ from the right. This particular part of the loop would still not get executed because this is to remove those elements out of the DQ which are outside the window. Right now we don't have any element in the DQ which are outside the window. So 1 would be popped out, or rather index 0 would be popped out of the DQ and 3 would be pushed into the DQ. That's what happens. Now we've still not seen at least 3 elements in the array. So we are not yet in the state to start building our solution. So we'll still not execute this part of the solution. Next we see -1, the incoming element. Now -1 comes into the play and it needs to get added at the end of the DQ because we will still be maintaining the order of the DQ. So it will get pushed in. This part of the loop again will not get executed because we don't have any other element in the DQ which are outside the window. This part of the loop will not get executed because we don't need to pop out smaller elements from the DQ. We will directly push -1, or rather the index of -1, which is 2, into the DQ. That's how it goes. Now we have 3 elements. We have already seen 3 elements. We are in a state to build the first element in the result. We will pick the maximum element from the DQ and we will push it to my result. I will pick the DQ. I will get 1, which is the index of 3. I'll push 3 into my solution. So I'll push 3 into my result, and that's how it goes. In the next part, I am saying 3 and I need to push 3 into my DQ, which I can do. Yes, I can do. I can push 3 into the DQ without disrupting the order of the DQ. 3 -1 and -3, which means there would be descending order maintained here. This part of the loop will still not get executed because we don't have anything inside the DQ which are out of the window, and we will directly push -3 into the DQ, or rather the index of -3, which is 3, into the DQ. And that's how it happens. We will pick the DQ now and try to see what is the maximum into the DQ. Picking will give us 1, which is the index of 3, which is the maximum element in the DQ. And that's how we store 3 into the result. Now moving on to the next iteration. 5 is the incoming element and I need to push 5 into the DQ, Before that, we have to check if any element in the DQ is outside the window or not. We'll be checking from the left if any element in the DQ is outside the window. The first element, this particular index is out of the window now because the window is moving from 2 to 4 and 1 is out of the window. I cannot keep 1 anymore to the DQ. This particular part of the loop is popping 1 from left. So that's what it's doing. That's how it happens. Other elements are already into the window, so I'll move to the next part of the loop, which is I have to push 5, or rather the index of 5, which is 4, into the DQ. I cannot do this directly because if I push 5, it will disrupt the order of the DQ. I need to keep it in such a way that it always maintains the descending order from left to right. Furthermore, if I already have seen 5, -1 and -3 are worthless to me now. They'll never become maximum in upcoming windows. That's why I will pop -3 and -2 in 2 subsequent steps from right. I popped -3, or rather 3, which is the index of -3, and I'll also pop 2, which is the index of -1. And now I'm free to push 4, which is the index of 5, into the DQ. That's what we do. Now we'll peak the DQ for the maximum element in the DQ, and then I'll just push it into the result. And that's what happens. In the next iteration, I would be seeing 3, which is the next element into the incoming window, and its index is 5. Before moving on to the next step, I'll be seeing if DQ has any elements which are outside the window. Right now it doesn't have any element which are outside the window. We have 4, which is already inside the window. So this loop would not be doing anything. We'll move to 3, this one. We need to push 3 into the DQ. Which, can we do it? Yes, we can. Pushing 3 will not harm the order. And 5 still remains relevant for us because it can still be maximum in the upcoming windows if there's a need for that. So for example, if 6 would have been 2 or something like that, 5 would still remain relevant for us. So that's why we cannot pop 5. That's the one reason. The second reason is we do not want to disrupt the order of the DQ. So we'll be pushing 3 into the DQ, or rather the 5, which is the index of 3, into the DQ. That's what we do. Now we will peak 4, which is the index of 5, we'll add it to the result, and that's what happens. Now we are seeing the newer element coming into the window, which is 6. We need to check if there's any element which is going out of the window. There's no element in the DQ which is out of the window, so this particular part of the loop will not do anything. In the next part of the code, we'll be pushing 6, or rather index of 6, which is 6, inside the window. Can we do that? No, we cannot, because that will disrupt the order of the DQ, and also pushing 6 or finding 6 makes 5 and 3 worthless. It will not become the maximum in any of the upcoming windows, so we need to pop 5, we need to pop 4, 5 being the index of 3, 4 being the index of 5. So we'll have to pop 3 first, and then we'll pop 4, which is the index of 5, and then we'll be able to push 6. We will peak the DQ for the maximum in the DQ and push it back into the solution. Now 7 is the upcoming element into the window. In the next section of the code, we will be checking if anything in the DQ is out of the window. DQ currently contains only element which is index 6, and it's not out of the window. This part of the code will not get executed, and we'll move to the next part of the code where we need to push 7 into the DQ. Pushing 7 into the DQ would disrupt the order of the DQ, and that's why we don't want to do that. We want to pop 6, which is the index of 6, out of the DQ, and then push 7. So that's what will happen. We will pop 6, push, and we will see the peak of the DQ, which would be 7, and we'll add it to my solution. And then finally we would end the loop because I don't have any more elements to see. And that's my solution. I've already built my solution now, and I'll print it. That's all for today, everyone. I really hope the visual explanation helped you understand the topic. Since I'm new to YouTube, your feedback is super important to me. So please let me know what you think in the comments. And if you want to support the channel and see more videos like this, be sure to subscribe. Thanks for watching.